Alright, so I'm going to go over everything that we covered in class on Monday and Tuesday, and everything we're going to cover in class on Thursday and Friday to get you ready for the quiz this week. So, first thing I want you to do is take out your notebook, and this is not your textbook, but your notebook, and numbers 1 through 8. Also, remember you can always pause the video if you ever need to, and rewind as well. So I want you to number 1 through 8. We're going to do some review problems of the stuff we covered before Christmas break. Here we go. Oh, and some other important information. All quiz retakes and projects need to be done by Thursday, January 13th at 4. Quiz 11 and 12 are the final scores to go on your grade. And for this week's quiz 11, you can use a 3x5 note card, which we will take this Thursday and Friday. A piece of scratch paper doesn't count, and I'm going to have you turn in your note card with your quiz when you're done. Alright, I don't know how many of you watched Spider-Man this week, or over the break, but there's a quote in there where he says, you know what's cooler than magic? Math. I thought that was really cool. Okay, here we go. So we're going to solve these functions we're going to evaluate these functions by looking at the graph. So, if I look at this first one, if I look and see what's replaced, I'm replacing the x with 9. So, if I come over here to 9, if x is 9, what's y going to be? Well, y would be negative 2. So, if x is 9, y is going to be negative 2. Okay, over here. So let's say we want to find the value of f of negative 6. So if I come down here to when x is negative 6, where does that meet my graph? What would y be if x is negative 6? So if x is negative 6, come up here to my graph, it'd be right here, which means that y would be 8. So that means f of negative 6 is going to be 8. You can also write it like this, y is equal to 8. Now what if it said, I want to find a value for x where y is 4. So what value for x makes y equal to 4? So if y is equal to 4, come over here to my graph, well, y is 4, x could be negative 4, and it could also be negative 8. So that means x is going to be negative 4, and x is going to be negative 8. Alright, here's the next ones. So, question 3, these are not continuous graphs, they're discrete, so it's just points. So if I look at this first one, I want to figure out what value for x makes f of x equal to negative 3. Or in other words, when y is equal to negative 3, what's x going to be? So if I come down here to when y is equal to negative 3, where on my graph is y equal to negative 3? Oh, well, right here. So if y is equal to negative 3, that means x is going to be negative 2. So if I put x is equal to negative 2, I could also write the answer like this, f of negative 2 is equal to negative 3. Okay, number 4. So here we know that x is equal to 0. So where in my graph is x equal to 0? Oh, well, it's on the y-axis. So where on the y-axis, so if x is equal to 0, what's my y going to be? So if we look at this, if x is 0, come up here to my graph, well, y is going to be 5. So that means f of 0 is 5. I could even say that y is 5. Remember, we can replace f of x with y. Those two are the same thing. Alright, let's go to question 5. So question 5. So I know that g of x is equal to this whole thing, negative 2x minus 1. So if I compare this to this, what changed? Well, I replaced x with 1. So in this equation right here, wherever I see an x, I'm going to replace it with 1. So negative 2 times 1 minus 1. Multiplication first. So g of 1 is going to equal negative 3. Okay. And those do 6. So same thing. I'm replacing x with negative 3. So here, wherever I see an x, I'm going to write negative 3. So I've got f of negative 3 is equal to negative. Now this is, got to be careful with negatives here. So x is negative 3, so I get negative 3 squared minus 12. So I do exponents first. So I got negative out here. And the negative 3 squared is going to be 9 minus 12. So f of negative 3, I've got negative 21. Okay, remember, if you ever need to stop, pause the video. If you ever need to go back and listen again, hit the rewind button. Okay, number 7. So these were like the last part of the homework from right before the break. So I want to figure out what value for x makes this whole thing equal 1. So I'm going to replace this whole thing with 1. I got 1 is equal to negative 5x minus 4. So now I want to get x by itself. So let's go back to what we did at the beginning of the year. So to get x by itself, I'm going to add 4 to both sides. Those cancel. Here I've got 1 plus 4, which is 5. Equal negative 5x. I want to get x by itself. I got one last step. Hang on, my computer's freaking out. There you go. I'm going to divide. Nope. Stop. Stop. I'm going to divide both sides by negative 5. Okay, those are going to cancel. So x is going to equal negative 1. Because 5 divided by negative 5 is negative 1. Okay, let's do it again. So my function is h of x, and that's equal to negative 5x plus 1. I want to figure out what value of x makes h of x, or this whole thing, equal negative 4. So I'm going to replace h of x with negative 4 and solve for x. So I'm going to get x by itself. First thing I'm going to do is subtract 1 from both sides. Stop. I'm going to subtract 1 from both sides. Those are going to cancel. I'm going to write it over here. Negative 4 minus 1 is negative 5. And it's equal to negative 5x. One more step to get x by itself. I'm going to divide both sides by hang on. We divide both sides by negative 5. So those are going to cancel. Those are also going to, well, not cancel, but reduce to 1. I end up with x is equal, stop. Man. I end up with x is equal to 1. Okay, so that's some review of what we did before the break. So now let's go on to some new stuff here. So here's our goals. Here's my joke. What do you call a fake noodle? An impasta. Okay. Alright, so let's think about the slope. Remember, the slope is rise over run. So if you think about what you learned last year in 8th grade, we talked about the height of the triangle over the base of the triangle. So the height of this triangle is 100. The base of this triangle is actually 2. So the slope is the rise of the triangle over the base of the triangle, which is going to be 50. Okay. We also talked about this formula last year. Okay, so if I got 2 points, I want to find what the slope is going to be between those 2 points. So we're going to do some more of that, but think of the slope. Also, if I were to find the slope between this point and this point, would it be any different than the slope between this point and this point? No, it wouldn't. It'd be the same thing. Right? I could even do from this point to... So I could even do from right here to right there. Okay, so the point being is that if we have a linear relationship, the rate of change is constant. So no matter what point on the line you pick, or what 2 points, the slope between those 2 points is always going to be the same. Now what if we have an equation like, or a function like this, a quadratic. So this is a parabola. If you look, the slope between these 2 points, from that point to that point, we're going to get a certain slope. Okay? If we were to look at the height of the triangle and compare that and the base of the triangle, the height of the triangle would be 2, and the base is 1. So it would be 2 over 1, which would be 2. It means from 0 to 1, our slope is 2. But what about from 1 to, let's just say this point right here. Is the slope from that point to that point going to be the same as from this point to this point? No, if you look, this one is steeper than this one. So this is called the average rate of change. So we're trying to find the average rate of change between 2 points. We're doing that because it's not going to be the same between every point. So we can compare the two. Remember this one right here. Remember this one right here is constant rate of change. This one right here is average rate of change. Okay? Alright, here's a 5-minute video I'll let you watch another time, but it talks about what I just talked about, the average rate of change of a function, and kind of talking about how it links into calculus. What's cool about that is calculus is really a way to understand how a lot of things in the world work. It introduces limits, but that's something you won't learn about until you get there, but it's cool to think about those things now. If you were in class, you have a 5-minute break. Okay, so in your notebook again, I want you to number 1 through 6. Okay, and leave enough space to show your work. So we're going to do some practice problems like the ones that are going to be on the homework. So remember, I got this formula, slope formula. So it's equal to y2 minus y1, that's 2, that's all over x2 minus x1. Okay? So, I want to find the average rate of change between 3 and 5. Remember, these are the x values because there's an x right there. Remember, right here on my table, these are my x values, and then these over here are my y values because I can replace f of x with y. So, each one of these sets of numbers is a point with an x and a y coordinate. So, I want to look at the average rate of change between 3 and 5. I want to look at this point and this point and find the slope between them. Remember, right here, this is the first point. This is point 1. Okay? Right here we've got my pen is struggling. It's point 2. Okay? Remember, each point has an x coordinate and a y coordinate. X coordinate and a y coordinate. So to make sure I don't get this y confused with this y right here belongs to point 1, so I'm going to give it a subscript of 1. This y belongs to point 1, so I'm going to give it a subscript of 1. So if this x belongs to point 2, what do you think I'm going to put here? I'm going to put a subscript of 2, and this y is also going to have a subscript of 2 because both those coordinates belong to point 2. So now, if I use my formula to find the slope, I've got m is equal to, my y2 is 81, my y1 is 9, that's all over my x2, which is 5, minus my y1, which is 3, okay? So my numerator, I got 81 minus 9, which is 72, and then 5 minus 3 for my denominator, which is 2. How many times does 2 go into 72? 36. So that means my average rate of change, or my slope, between those 2 points is 36. Let's do another one. Okay, so we want to find this average rate of change between 4 and 12. Remember, we're looking at our x values. So this is going to be 0.1, and this is going to be 0.2. So this is 0.1. I'm just going to do p, 0.1. This is 0.2. Remember, they each have an x, they each have a y coordinate. This x coordinate belongs to 0.1. Give it a subscript of 1. This y coordinate also belongs to 0.1. This x coordinate belongs to 0.2, and this y coordinate belongs to 0.2. So now, remember, if I want to use my slope formula, I got y2 minus y1 all over x2 minus x1. Now look, my y2 is 15. My y1 is 25. My x2 is 12. Oop. My x1 is 4. Okay? So 15 minus 25 is negative 10. 12 minus 4 is 8. Now I want to think if I can reduce that. Is there a number that goes into both negative 10 and 8? 2. So I can... 2 goes into negative 10 negative 5 times. And 2 goes into 8 4 times. So my slope, or my average rate of change between those two numbers, is negative 5/4. Okay, now let's look at a graph. So let's say I want to find the average rate of change between 0 and 1. Okay, so if I look at my x value, so my first point. Come on. Okay, so if x is 0, where do I get that from here? If x is 0, what's y going to be? Okay, well, if x is 0, it means it's on the y-axis. So if I come up to the graph, that means if x is 0, my y is going to be 40. Okay, 0.2. Come on. Okay, so if my, for point 2, x is 1, come on. Okay, so if x is 1, I'm going to come over here on my graph. So when x is 1, y is going to be 20. Okay, so now I'm going to use my slope formula again. Remember, I've got each of these has an x and a y. This x belongs with 1, this y belongs with 1, this belongs with 2, belongs with 0.2. Okay, so I'm use my slope formula. M is equal to y2, which is 20, minus y1, which is 40. That's all over x2 minus x1. Okay? 20 minus 40, negative 20. 1 minus 0 is 1. I can reduce those. That means my slope is equal to negative 20. Okay. Means m is equal to negative 20. Alrighty. Let's try another one. Okay, so this one's exponential. Let's do the same thing, or let's do between 1 and 2. So that means if x is 1, so I got 0.1. So if x is 1, what's 2 going to be? We'll come down to my graph. When x is 1, y is going to be 2. Okay. For my second point, so if x is 2, remember I'm getting the 2 from here. So if x is 2, from my graph, y is going to be 4. Okay, so now if I use my my formula here, remember this x belongs with 0.1, this y belongs with 0.1, this x with 0.2, this y with 0.2, so x1, y1, x2, y2, so now I've got m So now I got m is equal to y2, which is 4, minus y1, which is 2. That's all over. x2, which is 2, minus x1. So 4 minus 2 is 2. That's all over 2 minus 1, which is 1. Or our average rate of change, or our slope between those 2 points, is going to be 2. Okay, now let's look at an equation here. Okay, I got this equation. I have no idea what it looks like, really. But let's say I want to figure out what the average rate of change is, and we'll do the same numbers. Let's do between 1 and 2. Okay, so if I got my first point, try the mouse, see if that works better. If I got my first point right here, point 1. So at point 1, I got my coordinates. I know my first coordinate is 1, and that comes from up here. My first coordinate is, or my x coordinate is 1. Mouse isn't working any better. Okay. My first coordinate is 1. Okay, I got point 2. I know my x coordinate is 2. That comes from here. Okay, if I want to figure out what my y coordinate is for point 1, well, I know my x coordinate is. So I'm going to do what we did at the beginning of the day. And I'm going to replace x with 1. And solve. We're going to evaluate when x is equal to 1. So if x is equal to 1, whenever I see an x, I'm going to replace it with 1. I'm going to solve, but I got to do exponents first. I'm going to do 2 raised to the power of 1, which is just 2. So I got 3 times. Now I'm going to do multiplication. So 3 times 2. Which is 6. That means when x is 1, y is 6. So we're going to do the same thing with 2, but instead of replacing x with 1, we're now going to replace it with 2 and solve and figure out what y is going to be. So I got 3 times 2, instead of raising to the power of 1, raising it to the power of 2. Okay, so I do exponents first. So we got 3 times, remember 2 raised to the power of 2 is 2 times 2, so that's going to be 4. So equals to 3 times 4, and 3 times 4 is 12. So when x is 2, y is 12. So remember, I got an x here, which is my x1, and a y here, which is my y1, x here, which is my x2, and y here, which is my y2. So now I'm going to use my slope formula to figure out what the rate of change is between these 2 points. So my y2 is going to be 12. That's my y value that's associated with my second point. My y1 is going to be 6. My y value associated with my first point. My x2 is going to be 2. That's my x value that's associated with my second point. The next one is going to be 1. Now over here I'm going to do 12 minus 6, which is 6. It's all over 2 minus 1, which is 1. So I end up with the slope, or average rate of change, of 6. Okay. So I hope that helps. If you have any more questions, we're going to skip question 6 because my pen's not cooperating. But if you have any questions, email me or ask in class, and I will get the video posted of what we're going to go over on Thursday.